So like I'd said, we're on the back side of 10.4 here, and the discriminant is part of the quadratic formula. Part of the quadratic formula, the actually very, very important part. It's the part that's underneath the radical. It's b squared minus 4ac. Notice that it's not including the radical, but only what's underneath the square root. B squared minus 4ac.
That's what the discriminant is?
That's the discriminant. Okay, it's a part of the quadratic formula. In this case, just the b squared minus 4ac. So, it happens to be important because it helps me to determine whether or not there is no solution, one solution, or two real solutions. Okay, so there are three different things. One where the discriminant is, we'll say, bigger than 0. We'll say D for discriminant. Greater than 0. One where the discriminant is equal to 0. And one when it's less than 0. Three different situations. The graph where the discriminant is bigger than 0, the graph ends up crossing the x-axis twice. So here's my graph. I'll put a graph down for each one. The graph will cross the x-axis twice. It could be in a U shape or in an N shape, doesn't really matter, but it definitely crosses twice. Crosses the x-axis 2 times.
If it's greater than 0,
If it's greater than 0, then it'll cross the x-axis twice. If it's equal to 0, remember that's what's underneath the radical. Remember, then you're taking the square root of 0, that part disappears, the plus and minus part is gone. In this case, it touches the graph, and then it goes right back up. Now, again, it could be in the U shape or N shape, but it still just touches the graph one time. And that one time is your x value, the x-intercept, the solution to the quadratic equation. If it's less than 0. If it's less than 0, it never even touches the x-axis. It doesn't touch it at all. Your graph will never cross the x-axis at all. The number of real solutions here is the number of times that it crosses the x-axis.
It crosses or touches?
Crosses. So this one's going to be 2. This one is going to be just the one time that it actually touched the x-axis. And this one is 0. No real roots. 2 real roots when it's greater than 0. And when it's equal to 0, just the one real root. That's it. So let's go through just one example. It says to state the value of the discriminant for each question. Then determine the number of real roots of the equation. Here it'd be nice to identify what's the A, what's the B, and the C. Doesn't ask us to solve it, just to determine the number of real roots. So A in this problem is 4. Notice that I do have it equal to 0. So I can determine what's A, B, and C right away. But if it didn't equal to 0, I would need to get it equal to 0. So A equals 4, B equals negative 20, and C is equal to 25. So I plug this in, as is B squared. It's negative 20 in parentheses squared minus 4 times A. A is 4. C is 25. Notice there's no square root. I'm not taking the square root of this. It's just what's underneath the radical in the quadratic formula. When I plug this into my calculator, let's see what we get. Okay, again, make sure you put the negative 20 in parentheses. So negative 20 squared minus 4 times 25. Putting all this in, we end up with 0. So if the answer is 0 for the discriminant, that's one answer, right? Then it says determine the number of real roots of the equation. So how many real roots do we have here?
1.
So 1 real root. 2 answers. 1 for the value of the discriminant and 1 for the number of real roots. Now I get the feeling that numbers 2 and 3 would be pretty easy. You could probably even do them yourself, but we're down to only 2 minutes. It says in here, when the discriminant equals 0, number of real roots.